Hello everyone. In this video, we're going to learn about the periodic phenomena. Periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equivalent intervals. The period of a periodic function is the length of the s values that takes for the function to complete one cycle. Now let's take a look at the first example. The function f is periodic with period 4. Now we start from here and then you see that after 4 units the pattern repeating, right? So from here to here it's going to be 4 units, and after 4 units the pattern is repeating. And you see that the second shape is going to be identical to the first one, right? A portion of the graph of f is shown above. Draw 2 additional periods for the graph of f on the axis above. Alright, so we keep repeating this shape, right? So it's going to be like this. Now let's move on to the second example. A portion of the graph of the periodic function g is shown above. What is the least possible value of the periods of g? Alright, so we need to find the length of the s values that takes for the function to complete one cycle. Alright, so we need to know where it starts and where it ends. So we look at this one, we see that the pattern starts from here. If we split this one in half, so the pattern starts from here and end right here, right? And you look at the left hand side, it's going to be exactly right here. Alright, so the distance between these two guys right here is called the period. Alright, so if we count this one, it's actually 5. So the answer for this one is 5. Alright, now let's take a look at the example number 3. Using the function g and the periods found in example number 2, find the following values. Now observe that the periods of the function g is 5, which means after 5 units, the function completes one cycle, which means it's go back to original one, right? So for example, we start right here. Okay, so after 5 units, the pattern repeating. Alright, so if we need to calculate g of 14, we need to write 14 in terms of 5. Alright, so 14 right here can be written as g of, right? Now I need to write 5 over here, right? This is my periods, right? How many times for number 5 go into number 14? The maximum is 2, right? So I have 2 times 5, right? The remainder I'm going to put right here, which is 4, right? So I only care about this guy. I don't need to care about this guy anymore, because after 2 cycles, the function comes back to original one, right? So g of 14 is the same thing as g of 4, right? G of 4. Alright, now I look at this one, g of 4 right here is going to be 7, right? So the answer is 7. Now let's move on to question B. Alright, so I do the same thing. It's going to be g of something right here. I don't know it. But I know that the period is 5, so I write 5 over here. Alright. Now, how many times for number 5 go into 72? Does that mean it's going to be 14, right? So I put 14 right here times 5 equals 70, right? And then I have remainder is 2, so I put 2 right here. Right? Alright, so this one right here tells us after 14 cycles, the function comes back to original point, right? So g of 72 is the same thing as g of 2. Alright, but g of 2 right here is going to be right here, which means 6, right? Now let's move on to question C. G of negative 17 can be written as G of, right? Now I know that the period is 5, so I write 5 over here. Alright, so I look at 17 right here. How many times for number 5 go into 17? So does that mean maximum is 3, right? So I have 3 right here. Alright, multiply this. Now, 3 times 5 is going to be 15, right? So I have 2 as a remainder, right? So I put 2 right here, right? So now I have the negative side right here. So does that mean negative 2 minus 15 is going to be negative 17, right? So this guy is the same thing as g of negative 2, right? Now g of negative 2 is going to be right here, right? This is negative 1, negative 2. So the answer is 7, right? Now we have another way to do this one. Now we look at this one, we see that this is g of negative 17, right? Now we need to write this one as g of, alright, I know that the period is 5, so I put 5 right here. Alright, so instead of 3 cycles, I put 4 cycles right here. 4 times 5, right? So it's going to be 20, right? But we have negative 17, right? Does that mean 3 minus 20 to get negative 17, right? So then this guy turns out to be g of 3, right? Now g of 3 is going to be 7, right? So the answer is 7. Now let's move on to example number 4. The graph of the function h is periodic with a period of 5. The values of h are shown above. Find the values of h of negative 2. Alright, so we look at this one. We don't see any negative 2, right? So we need to use the period of 5, right, to rewrite this one in terms of the period of 5, right? So h of negative 2 can be written as h of parentheses. Now you need to put 5 right here, close parentheses, right? Alright, so negative 2 can be written as 3 minus 5, right? Alright, so this guy is the same thing as h of 3, right? Because we can ignore the periods, because after one period, it's going to go back to original one, right? So we just care about the number 3 right here. So h of 3 is going to be 0 right here, right? So the answer is 0. Now let's move on to question B right here. H of 6. So we look at the table, we don't see 6, right? So we need to write 6 in terms of 5, right? So this one is the same thing as h of. Now we need to write the periods right here. Periods is 5, right? So we have 6, but we already have 5. So does that mean we need to add 1, right? So I have 1 plus 5, right? So this guy is the same thing as h of 1, right? I look at this one, h of 1 equals negative 2. So this guy turns out to be negative 2, right? Now, question C, h of 9, right? So we need to separate this one, right? So we need to calculate the inner function first. The inner function is h of 9, right? So I put this one on the side, h of 9, right? So I need to write h of 9 in terms of the periods of 5, right? So it will be h of Now I need to put the period 5 right here, right? And then right here I already have 5, but I need 9, so does that mean I add 4, right? Alright, so this guy is the same thing as h of 4, right? Because I can ignore the periods. Now, h of 4, I look at this one, it could be 3, right? So 3 right here. But it's not the final answer, right? Because this is just the value of the inner function, right? Now, what we need to do is to calculate h of this guy right here, right? So h of 9 is the same thing as h of 3, right? And look at this one, h of 3 right here is going to be 0. Now let's move on to question D. We need to solve for h of 5k minus 3, right? So where k is an integer, right? So we know that the period of the function is 5. So 5k, which means this is the multiple of 5, right? So after the multiple of 5 periods, the function comes back to original one, right? And then this one can be written as h of negative 3 plus 5k, right? Now I can ignore this one, right? So this guy turns out to be h of negative 3, right? So I look at the table right here, I don't see negative 3. So I need to manipulate this one a little bit, right? And I need to manipulate this one in terms of the period of 5, right? So I need to write h right here, parentheses. Now I need to put 5 right here. And then close parentheses, right? Now, h of negative 3, but I already have the period of 5. Now I could put 2 right here and I subtract this one. So then this guy turns out to be h of 2. Right? But I look at this one, I don't see any value of 2 right here. So this way doesn't work. Alright, so I need to find another way. Right? So 5 right here is just one period. What if I multiply this guy by 2? Which means 2 periods, right? So this guy 2 times 5. Alright, 2 times 5 equals 10, right? But I need negative 3, right? So does that means 7 subtract 10, right? So this guy turns out to be 7 subtract 10 to get negative 3, right? So this guy is the same thing as h of 7. Keep in mind, when you manipulate this one, but the number is not right here, you need to find another way to manipulate this one, right? Alright, so h of 7 is going to be 2 right here. Now, we can consider a periodic function as a horizontal translation itself. In example number 4, the period of the function h is 5, right? Which means we can translate the graph of h horizontally 5 units. And then we're going to end up with the same graph. This means the function h satisfies the following equation right here, which is you learn in transformation, right? If f of s minus h plus k, right? And then this guy, if h positive, the function translates to the right. If h is negative, the function translates to the left. Alright, so keep that in mind. Alright, so we look at this one right here, example number 5. The graph of the function f is periodic with a domain of all real numbers, right? So, which means s can take any number on the s-axis, right? Now, 2 full periods are shown. Find all input values, which means you need to find the value of s. Of the function f that yield an output value of 1, which means y equals 1, right? S equals what in order to get y equals 1, right? So look at this one, 2 full cycle, right? So the function start from here and end right here, right? So we look at this one, we see that the period is 4, right? And then this pattern keep repeating to get the new one right here, right? So the period is 4. Now, the question asks you to find all value of s such that the y value is 1, right? So we look at the bottom right here. We see that the value of y is equal to 1 right at this point and this point, right? And we know that the period is 4. So after a period of 4 units, the pattern keeps repeating, right? So this is where we start. So we know that f of 2 equals 1, right? And the next one right here, which means f of 6 equals 1. Of course, the next number should be f of 10 equals 1. The next number should be f of 14 equals 1, right? Because the pattern keeps repeating after the period of 4 units, right? Now, it takes you forever to get this one, right? So we need a general formula, right? So we start from here. It's going to be 2. And then we add 4 every single time, right? So we have 2. And then next one should be 6, right? This is s value. Keep in mind, this is s value. Now the next one should be 10. So we write it right here. The next one should be 14, right? 18, etc., right? So we see that every single time you add 4, right? So this is actually arithmetic sequence with the common difference is 4, right? So d equals 4. Alright, so the recursive formula for the arithmetic sequence is a sub n equals a sub 0 plus the common difference and multiply by n, right? So this guy turns out to be a sub n, which means s right here. So I replace a sub n with s. A sub 0 is going to be 2 right here. Plus the common difference is 4. Alright, multiply by n. That's it. Alright, so this is the general formula for the input value right here. Now let's move on to the next example. Example number 6. The figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. Alright, so we know that the distance from here to here is going to be 8 inch, right? The center of the clock is 120 inches directly above the floor. So this is the center. The distance from here to here is going to be 120 inches. However, at time t equals 0 minutes, the minute hand is pointed directly up at the 12, right? So right here, t equal to 0. However, the clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to the 12 is as the minute hand moves, the distance between the end point of the minute hand and the floor periodically decrease and increase. Alright, so what you need to do is you need to draw the midline, right? This is the highest point. This is the lowest point. Right? The midline should be right here. Alright, now t equals 30, which means this is the period. Alright, so we have 4 points right here. T equals 0, and this guy right here is the midline. And go over here. Now it takes the minute hand 30 minutes to complete a full cycle, right? So go over here, it's going to be 1/4 of 30, right? So right here, t equals 7.5. Right here, t equals 15. Right here, t equals 22.5. And go back over here, t equals 30. So basically, t equals 30 and t equals 0. They overlapping, right? Now, question A. The graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scales is indicated and no axes are represented. Now determine the possible coordinate of the point F, G, J, K, and B, right? So we look at this one. We start from here, right? This is a point F. Point F when t equals 0. And then the minute hand point directly at 12, which means this is the highest point, right? You know that the minute hand is 8 inches, right? And then the distance from here to here is going to be 120, right? So the total distance is going to be 120 plus 8. So right here, point F has the coordinate 0, 128. Now, we're going to move on to point G right here. Point G is the point right here. Right? Because point G is on the midline, right? This guy right here. So, t equals 7.5 and the distance is from the center all the way down, which means 120 only, right? So, G should be 7.5, 120. Alright. Now, point J right here is the lowest point, which means it's going to be right here. Alright, so point J is going to be t equals 15, right? And then the distance from here to here is going to be 120 subtract 8 because the distance from here to here is going to be 8 right here. Alright, so 120 subtract 8 should be 112, right? So this guy should be 15, 112. Now, point K is going to be in the midline, right? So this is the point K right here. So point K right here, t equals 22.5, right? So 22.5. The distance is from the center all the way down, which is 120. So this guy should be 120. And the last point is point P right here. Let's go back to original one, which means t equals 30, right? And then the distance should be 128, right? Which means from here all the way down, right here. Now, question B. Refer to the graph of the function h. In part A, the t-coordinate of the point G is t1, and the t-coordinate of the point J is t2, right? On the interval t1, t2, right? So point G is right here. And point J is going to be right here. Alright, so the function is right here. That's it. Okay. On the interval t1, t2, right? Which means the interval from 7.5 to 15. Which of the following is true about the function h, right? Now we look at this one. The function h is positive and increasing. No, the function is decreasing, right? Because the rate of change is negative. If you draw a tangent line right here, and then you're going to use the Christmas tree trick right here. Alright, if the lines go in this way, the slope is negative, right? So because the slope is negative, the function is decreasing, right? So it's not right because it says the function is increasing, right? So this is wrong. Question B. H is positive and the function is decreasing. The function is decreasing, this is right. h is positive. Yes, we're going to check this one. The function is positive, which means we're going to look at the y value. The y value is 120, is positive. The y value is 112, this is positive, so this is the right answer. Now we're going to check C. The function is negative. No, there is no negative output, right? Look, the output is positive, so this is wrong. The function is negative. No, it's wrong. So the answer is B. Now, this question, describe how the rate of change of the function h is changing over this interval, right? Which means from 7.5 to 15, right? The interval right here, 7.5 and 15 right here. Now, we look at this one. We see that the function right here is concave up over this interval, right? So, because the function is concave up, the rate of change of the function h is increasing, right? So we just say on the interval t1, t2, the function is concave up, so the rate of change is increasing. Now let's move on to the next example. Alright, so this example is similar to the previous example. Alright, so on the interval t1, t2, which of the following is true about the function h? Now, t1 is the coordinate of the point k, right? So point k is right here. And t2 is the coordinate of the point p, right? So point p is right here. Alright, so point k right here. Now, the function should be this guy. Alright. Now, over this interval, the function is increasing, right? Because if you draw a tangent line, right? And you use the Christmas tree trick, right? If the lines go in this way, the slope is positive. And when the slope is positive, the function is increasing, right? So I'm going to eliminate B and D, right? Because it says decreasing. Now, I'm going to check the next one. Now, if the function is positive or negative, I'm going to look at the y value of the points P and K, right? They're both negative. So the function is negative, right? So the answer must be C. Negative and increasing. Now let's move on to the next example. The following graphs show one period of the periodic function. Alright. We need to sketch the rest of the graph, right? So we need to find the periods first. Alright, so we start from here. Alright, and then we end up right here. Keep in mind, in order to find a period of the periodic function, you need to know where the function starts and where the function ends. In other words, the period is the distance of the s value where the function starts and where the function ends. Now, how do we know where the function starts and where the function ends? It means that the function ends where it starts. Now, the function starts right here, right? You see the line, the horizontal line right here. And then the endpoint should be this guy, right? You start from here and you end on the same line. So keep that in mind. So the distance from here to here is the period. So we have 2 right here, and this guy should be 5. This is 6. This is 7, 8, 9, and 10. Now you take 10, you subtract 2. It's going to be 8. So we have the period is A. Alright. Now, after 8 units, the pattern keeps repeating, right? Alright, so we're gonna sketch this one. It's gonna be something like this. We know that the period is 8. Now, is the function increasing or decreasing or both on the interval 52 and 56? So in order to know if the function is increasing or decreasing or both on this interval right here, Now we need to write 52 and 56 in terms of 8. So keep that in mind. Now how many times for number 8 go into 52? So does that mean it's going to be 6 times, right? So 6 times 8 is going to be 48. 52 subtract 48. It's going to be 4. So the remainder is 4, right? So 52 can be written as 4 plus 6 times period, right? Remember the first two examples we did it. So instead of 52, you can write 4 only. Alright, so 52 is the same thing as 4 less than. Now 56 can be written as 6 times 8 plus 8. Right? Because 6 times 8 is going to be 48. And then plus 8 is going to be 56, right? So you only care about 8 because this one keeps repeating, right? So 56 is similar to 8, right? So this guy less than 8. Now the interval should be from here. This is 4 and this is 8 right here. So the interval right from here to here, right? So the function is decreasing, right? So this one decreasing. Now, the interval from 30 to 34, right? Again, 30 can be written as, we need to write the periods right here, 8, right? So, how many times for number 8 go into 30? And what is the remainder, right? So, it should be 3, right? 3 times 8 equals 24. We have remainder is 6. So we need to add this one. So 30 similar to 6, right? So I just write 6 over here. Less than as less than 34. Now 34 can be written as, rewrite the periods right here. Alright, so we're gonna multiply by 3, right? And then we're gonna add 6, right? And then we're gonna add 10, right? Because 10 plus 3 times 8 is going to be 34. So 34 is the same thing as 10, right? So we put 10 right here. Alright, so in this interval 6 to 10, so 6 right here, and then 10 right here, right? The function is this guy, which means the function is concave up, right? So this guy right here. Now, is there a relative maximum, relative minimum, or neither? S equals 44, right? So 44 can be written as, rewrite the periods right here, right? Alright, so how many times for number 8 go into 44, right? Does that mean 5, right? So you have 5 times periods. Then add the remainder 4, right? So we just ignore this guy, right? And we look at this one only. 44 is the same thing as 4, right? So we look at 4 right here. It should be relative maximum. So the answer is right here. So let's move on to example number 2. Now we need to find the periods first, right? So the function starts from here and ends right here, right? On the same line. Keep that in mind. It should be on the same line, right? The function ends where it starts, right? So it starts from the horizontal line right here and it ends on the same horizontal line. So the period should be the distance from here to here, right? So the period is 5 subtract 1, right? So 5 subtract 1 is going to be 4. So the period is 4. So keep that in mind. Alright, so is the function increasing, decreasing above on the interval 25 to 27, right? So we need to write 25 and 27 in terms of the periods, which means in terms of 4, right? Now I need to write 25 in terms of 4, so 25 equals. Now how many times for number 4 go into number 25, right? It's going to be 6, right? So I just will write the periods right here, 4, right? So I have 6 times 4. and then I have remainder is 1, right? So 1 as 6 times 4. Now I need to ignore this one. I don't care about this guy, right? So 25 is the same thing as 1, right? So I put 1 right here, less than as. Now 27 is going to be 3 plus 6 times 4, right? Alright, so it could be 3 right here. So less than 3. Right, so from 1 to 3, it's going to be this guy right here. Alright, the function is decreasing. Now next one, 34. Right, you need to write 34 in terms of 4, right? So 34 equals 4 right here, right? So how many times 4 number? 4 go into 34, it's going to be 8 times, right? 8 times 4 and the remainder is 2, right? So 34 is the same thing as 2, right? So I just write 2 over here, less than as. Now 36 is the same thing as 4 plus 8 times 4, right? Now 4 right here is the same thing as 36, so it could be less than 4. So from 2 to 4, right? So this is 2, 3, 4, 4 right here, right? So 2 to 4 is going to be this guy right here. So from 2 to 4, the function is concave up. Now, is there a relative maximum, minimum, or neither, right? As x equals 47, so you need to write 47 in terms of 4, right? So write 4 over here. How many times 4 number 4 go into 47? So it should be 11, right? So 11 times 4 is going to be 44, and the remainder it should be 3, right? So 47 is the same thing as 3, right? So right at 3, it's going to be right here. The function has relative minimum right here, right? So the answer is relative minimum. And then you need to complete this graph. So basically it's going to be something like this. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in